well, we're rolling now. Okay, let's continue. So, I think that was the last example I gave. We're going to continue with substitution. I think this was 5.4. Here's one for fun. Try that one. And now let's look at a definite integral. 0 to 3 of 3x over 16 plus x squared. Okay, ideas? This one first.
We're gonna substitute 1 plus radical, everything inside parentheses for u.
Right.
And d.
That guy was what's making things complicated. If he wasn't there, if he was a single variable, we could just move up and do the power rule, right? So that part is complicated. Okay, so that's it. Does the first check, making that a single variable would make things easier, but does it check out? The derivative would be?
I think that would be like 1 over 2 radical x. Well, there's your radical x over there.
Yeah,
There's
1 over radical x. It's off by a constant, but we don't care. So what do? Well, the way we've been doing it, we'll continue. Solve for the dx. So dx would be 2 radical x du. And then we're going to plug that in. So we have the integral here, 1 over radical x. We didn't do anything with that. This guy we made a u. So now that's just times u squared. And then the dx is now replaced by 2 radical x d. This will cancel that guy. And I have the integral of 2 over 1 over u squared. How do I do with that?
Move the u up and power rule, or the opposite of power rule.
Yeah, so one thing you want to remember, I see this happen all the time. Students will try to do the power rule while something is in the denominator. You cannot do that, that's illegal. You have to make it look like a power rule in order to do the power rule. So if you put u cubed over 3 under here, you're already wrong, because that would not be the right answer. And if you think that that's ln, it's not ln because it's a squared. Ln has to be just 1 over the first power, which I should emphasize that more, but because in 209 that gives people a lot of trouble, but whatever. We'll continue. So this is the right way to do it. You move it up, now it looks like a power rule. You have a variable to a constant power. So we have, what's it going to be?
U minus
negative
3?
No.
Negative 1.
Minus 1.
Minus
You
1.
add 1 to the power. So minus 2 plus 1, divide by the new power. So that's, divide by minus 1, multiply by minus 1 is the same thing. And then I just replace my u with what it was. Yes?
Why did you put radical x? Like after you find the dx, that step after that.
It comes here. Yeah, so once I find my u and my du, I'm going to go back to this integral and start swapping things out. Because as it is now, it's complicated. So I want to make it easier. So I'm going to go back and start plugging things in. So my 1 plus radical x was u. So this thing gets replaced by u, which gives me this.
Oh, I didn't. Okay. Cool.
Right. The radical x, I didn't do anything with it, so I left him alone. And then my dx, I have to change, but my dx is this. So this whole thing here plugs in here. And I get that here. So my radical x cancels, and I get something that's a lot easier now with just the power.
So that step can be like substitution.
Yes, that's where the name substitution comes from. Now we're substituting these guys into that.
Okay.
We're substituting functions of use for functions of x. Yep.
This may sound like a silly question, but anytime you write like integral of f of x, why is it always necessary to slap on the dx at the very end?
Because it's telling you who your variable is. Right, so at this point in Calc 1 and Calc 2, you're not really going to see a point to all this, but it's something like Calculus 3, where you're dealing with several variables at a time. You always want to know which variable am I integrating, which variable am I differentiating, which variable I'm doing that. Because you're going to be doing calculus on multiple things all at once. So you need to know who you're doing what with. So that's why. So as far as Calc 1, as far as you're concerned, it's just notation. But it really becomes useful in multivariable calculus. Because dealing with several things at once, you can have x's and y's and z's mixed up, and you'd have dx, dy, dz, or dz, dx, dy, and they all would mean something different. Yeah. So yeah, this is just, think of it as a way to identify who your variable is. Kind of like how when you had dy, dx, it was identifying this guy's the independent variable, that guy's the dependent variable. So you can just think of it as identifying who your variable is. What about this one? Okay, so now this is a definite integral, remember, because we have numbers here, which means the fundamental theorem of calculus would apply. So it means once we get here, we're going to have to be plugging in these numbers. However, this formula here is not one of our basic formulas. You're going to have to do a substitution here. There are two ways you can proceed when doing this. So let's do one. Proceed as usual. Back substitute. And plug in the limits. That's one way to attack this. Which, especially in this class, this is probably the way I would stick with it. This would be the method that I stick with usually. There are other integration techniques that makes this kind of annoying to do, but we're not covering them. Substitutions as high as we're going. But if you go into like Math 202, there's something, for example, called a trigonometric substitution, where doing it this way is kind of really annoying. So, but for now, let's actually go straight forward and get through this. So if you have 0 to 3, 3x, 16 plus x squared dx. So how do we proceed as usual?
U 16 plus x squared.
Yep, u equals 16 plus x squared.
du is going to be 2x.
2x dx. So your dx is going to be du over 2x. Okay, so now you're going to substitute these guys, right? So we have our 3x here over, that guy's just radical u, times, I'm going to have my du over 2x. These x's will cancel. And I'm going to be able to bring that 3 over 2 on the outside. So it's going to be 1 over radical u du. Now here's something that you have to be careful about. These limits here went with the x, right? U is something entirely different. So what I'm saying is here, don't worry about the limits, just keep in mind that these guys go with x. So what I would do is I would write x equals 0 up to 3, just for emphasis to remind myself. 0 and 3 go with x, not with u. So you're not going to be plugging these numbers into u, right? I'm going to go all the way to the end until I get back to a function of x as the answer, and then I'm going to plug in those numbers. Okay? So what's next? After I get to that stage, what's going to happen?
You can
You plug
rewrite
back
the
in
u.
16 plus x squared.
It'll be, if I rewrite that, what is it? U to the minus 1/2, right?
Yeah.
And x goes from 0 to 3. So I integrate that, I get u to the 1/2 divided by 1/2.
I believe I'm using.
What?
Are we not putting x back? Okay.
I didn't integrate yet.
Okay.
I have to first actually integrate it to get the answer. So I'm doing the power rule right now,
Oh,
right? And so now at this point, I know my x goes from 0 to 3. And this guy's gonna cancel that. I would end up with 2 u to the 1/2, x goes from 0 to 3. Now do not make the mistake of plugging this 0 into u and the 3 into u, because that would be wrong. X's are those values. So what I'm gonna do first is now back substitute and then plug in the limit. So I'm gonna take my u back, which was 16 plus x squared. So this is 3 times 16 plus x squared. And now I can plug in 0 and 3. So I plug in the 3, I get 3 squared to the 1/2 minus 16 plus 0 squared to the 1/2. And that's 16 plus 9, that gives me 25 to the 1/2, that's 5 times 3, that's 15. And 16 to the 1/2 is 4 times 3 is 12. So that's it. So typically, especially in Calc 1, that's how I would do it. I wouldn't worry about the limits too much. But there's another way to proceed, is to actually change the limits. And that, in this case, you don't have to back substitute. Because there are some integration techniques that back substitution actually is something really annoying to do. But in 205, it's not going to be. I just proceed this way. But I'll show you guys anyway, just in case anyone has a personal preference. There's nothing wrong with doing it. So again, here you proceed as usual. You'd start with u equals 16 plus x squared. You'd have your du is equal to 2x dx. And you'd have your dx is equal to du over 2x. And now what you would do here is you change the limits. Right? So you don't want 0 and 3 anymore because you're getting away from x's and you're going to u's. So you have to find out what are the corresponding u values. Right? So what you would do here is you'd use the substitution equation. So here, I know that when x equals 0, u would be equal to what? Yeah, it's going to be 16 plus 0 squared equals 16. And then I say when x equals, the other guy I'm going to want to change is the 3. My u is going to be, I'm going to plug in x equals 3. 16 plus 3 squared equals 5. And so now when I start to rewrite this integral, I'm essentially going to get the same thing I did before. I'm going to get that 3 over 2 u to the minus 1/2 du. Except now my limits, I change them. So instead of the 0, I now have 16. And instead of 3, I now have 25. So then you integrate that with the power rule. This cancels that. And so right now you can literally just plug these numbers in without going back to the x. And you'll end up with the same answer. Right? So there's just a slight change. It's just a matter of whether you want to go back to x's or not. Right? If you don't want to go back to x's, you'd have to actually change the limits, because the limits, it depends on the variable. Right? So this 0 and 3 goes with x's, and you can actually change the limits if you prefer to just plug back into the u's. I tend to go with method 1 unless I'm doing a more sophisticated technique. Substitution, I don't think it's worth it. But again, it's a personal preference. Any questions? That's it.
see where we have like 3 to 0 and 0 to 3? Will
Yeah.
they ever be fractions?
They could be, but I wouldn't put fractions. I can't promise that if you plug them in, you won't get a fraction here.
Yeah, but like the numbers
But no.
themselves won't be fractions. Or
No, I wouldn't put fractions. It's possible for them to be fractions, but I would put fractions. Okay, so here we're going to do one application of integrals. Areas between curves. So remember that one interpretation of the integral was the net area under a curve. There are many times where we actually want to find the area between two curves, and it will have some sort of physical or otherwise interpretation, but for right now we're just focused on the calculations of doing this. So here's what you want. Suppose we want an area between some function f of x and g of x on some interval. And so for example, let's say I have, that's my f of x, that's my g of x, and I'm on the interval ab, and what I want is actually the area in between these two curves. That is the goal. I want to find that area. So here's how we're going to approach this problem. If I ask you what was the antiderivative of a to b of f of x dx on this interval, what would that actually give me?
Isn't like
Big F of B minus big F of A.
No, in terms of this picture, what does that give me?
Area.
Area, which
A
area?
to B up to the function.
Up to the function f, right? So here's my f here. This guy would give me
Subtract.
this whole thing, right? Yeah. Now if I take the integral of g on a to b, what would that give me?
Area of below G.
Area below g. So here's my g of x here. And this would give me that area. So how do I find the area in between them? Subtract, right? If I take this area and I subtract that area, I will get, so here if I look at f of x dx minus g of x dx on AB, which by the way, by our properties, this is just integral of a to b of f of x minus g of x dx. That is going to give me the area between them, right? Because one integral is going to give me this, another integral is going to give me that, and when I subtract them, I get this, right? Take the bigger area, subtract the smaller area, you're left over with what's in between. That's the idea, right? So, in summary, basically what I just said. A, meaning the area between two curves, is the antiderivative, let's put an interval on AB, is the antiderivative of the top function minus the bottom function. That's the main takeaway. That's what you really want to remember from this. We won't really cover this case, but I'll just mention it anyway. function that we want. So there's another idea where I can look at functions as functions of y. So I can have an f of y and a g of y between the y values c and d, and I want to find the function between those guys. And so in this case, top and bottom becomes right and left. And notice you have functions of y. So here, if I'm looking for this area, that would be the integral from c up to d of g of x, g of y, minus f of y, dy. In other words, it's the antiderivative of right function minus left function. So the idea is top minus bottom or right minus left. We're not going to deal with the right minus left guy. That's more of a 201, 202, 203 concept. But yeah, eventually you get to places where you can think of things as functions of y or functions of x, which is why this dx is now important, because it tells you what variable you're looking in terms of and how you're looking at the world. If you want to look at the world this way or look at the world that way, because it might be advantageous one way or the other. Yes?
Can you put them together and have, you know, 4 curves and find the area within that?
Yeah. And there are times when one might be more efficient than another one. So if you look at an area like this guy, say you wanted to find an area somewhere that's like this. Right? Now in that scenario, the right minus left would actually work out better for you, right? Because imagine if you're over here, right? Your top function is the parabola. Your bottom function is the line. If you're over here, your top function is the parabola. Your bottom function is still the parabola. It's not the line anymore. So your bottom function switched. Now every time you do a top and a bottom, you need a whole new integral to deal with that top and the bottom, right? So if you're doing the top and the bottom idea here, you need 2 integrals. However, if you're doing right and left, no matter where you are, on the right side, it's always going to be the line. While on the left side, it's always going to be the parabola, right? So for an area like this, I would use the right minus left instead of the top minus bottom. I'd write things as functions of y and do dy, and all my limits would come from the y-axis. And yeah, you can have regions that combine all these areas, especially if you're in like economics, you're gonna have graphs all over the place and you need to find the intersection of stuff. All these demand curves and price functions and all sorts of things. So there are many situations where you'll have like graphs like, right? And you have to find this like weird area. So you might do a right minus left on a piece of it and a top minus bottom piece of it. You can have things getting crazy. Yeah, but we're keeping it simple here. In 205, we're just basically doing top and bottom. Right? So you won't have to change variables usually. So let's actually just jump into this and do some examples. Or let me make a note first. The interval may be given. Right, so I can say find the area between these 2 curves on this interval, and that's fine. More usually, we just say find the area between 2 curves, and the interval would be defined by the intersection points. But you should be fine to do either case. I have examples that cover both cases. You'll be given boundary curves. So the picture that I drew in the first place when I was explaining this concept covers this case. In this case, what you might see is something like, I just say find the area find the area of the region bounded by the curves. So sometimes you might be given functions that they're doing their thing, but this would be the area between these curves, right? So here are the 2 points where they intersect. Let's say I call that f of x, call that g of x. And you weren't told an integral. I just say find the area in between these curves. So I'm going to find the region that's trapped between these two curves, and I want the area of that thing, right? So this A and the B are intersection points. In this situation, you wouldn't be given them, you'd have to find them. So in this case, what would the area be?
F of G of that.
So the integral is b, which is like on the bottom should be b.
Where?
On the integral.
A.
A up to B, right? You also go from
Yeah.
left up to right,
And then f of
No,
no,
G of X.
g of x minus
G of x minus f of x. Y.
top minus bottom.
Top minus bottom, right? Pretend you're a little man trapped into the side of this thing, look up to the ceiling, who are you looking at? You're looking at G. You look down on the floor, you're looking at F, right? It's always top minus bottom. Okay. And every now and then, you'd have a situation like this. So I can call this h of x, that k of x. So these are branching off. So the area trapped in between them would be this. Now let's say you find these intersection points. Call that A, call that B, call that C. How do you find the area in between these?
Equals into the integral of A to B of k of x minus h of x, and then do it again. Integral.
And plus, right? So what you're doing, you find this area and then you're going to add it to that area. So it's going to be to C of
h of x to k of x.
yeah, it'll switch.
Minus x.
So here you see that it switches on you, but you always have to do top minus bottom. So in each region, you're going to have to see who's on top, who's on bottom, right? So if you have several shaded regions and your functions like switch on you, you need a whole new integral to take care of that. So there are times when the functions themselves will define the intervals for you. Other times you'll be given them. Okay. Just want to make sure that idea is clear. So now let's jump into the examples. Let me mention something else. As a warning, I guess. Back to day one, you will need to remember how to solve polynomial equations. And solve equations in general, but the functions you're given are usually polynomial. So if I give you a random quadratic and ask you to find the roots, or a random cubic and ask you to find the roots, you should be able to find the roots. 2. You should be able to graph things.
Is this gonna be an exam tomorrow?
Yep. Graph functions quickly, as in not. when I say graph function quickly, I basically mean at the level of pre-calc. So you won't need to find a concavity, and I don't care about inflection points anymore. Just a rough sketch of something. Right? Because you're basically going to want a picture that you're going to be able to see, oh, that's the top function, that's the bottom function. So just do a quick sketch of how things will look. So it's been a while since we've done any of that, so make sure you review those two things. Graphing is important, solving equations is important. Right? In general, you solve polynomial equations by what? Bringing everything to one side, factoring, setting each factor equal to 0. Right? So a typical problem would look something like this. Sketch the region bounded by the given curves and find the area in between them. So something like that, very similar phrasing. And here's one example. So here you'll be given two curves. Let's say y equals x squared and y equals x plus 2. So we'll pretty much go here. First thing you're going to do is sketch it. What does y equals x squared look like? Parabola. What does y equals x plus 2 look like?
Well, a diagonal line, just it starts at 2 above the origin.
So like this?
No.
Other way, like that.
That goes through 2. So the area they're talking about is this, right? And that would count as your sketch, right? So that's sketch the region, that's what you'd write, right? You'd want to identify, obviously it's the area bounded between the two, so this here is going to be one of your limits. This here would be the other limit, right? So we need to find the limits. So now what you're going to do is you're going to find the limits. These would obviously come from the intersection points. How do you find intersections?
So those two equations equal to each other.
Yeah, basically plug one function into the other. So if I know y equals x squared, I can take this and put it into y over here, which basically, in this case, is setting them equal to each other. Now I need to solve that equation. How do I solve it?
Subtract x on both sides.
Subtract x plus 2 on both sides. We're big kids now, we can subtract two things at once.
Oh,
Right? You don't have to move over the x. Next step, move over the 2. We don't do that anymore, it's calculus. Right? So bring everything all at once. Now what?
factor.
Which is?
And it's x and x.
Minus 2 plus
1 minus 2.
Right, so it's 2 and 1. Two things is multiply, I get -2, add, I get -1. That must be a minus, that must be a plus. So you would have x equals 2 or x equals -1. So you know here, that intersection is -1. This intersection is 2. And so now we can find the area. This implies our area is going to be equal to the integral from -1 to 2 of top minus bottom. The top is
X plus 2.
the line, which is x plus 2. Minus, parentheses, very important, the bottom is x squared. So it's x plus 2 minus x squared dx. What's that?
That's literally like Actually, no, I'm thinking of this. X squared over 2. 2x. X cubed over 3.
So it's just a power rule everywhere.
Yeah.
Now we're going to plug in that top number. 2 squared over 2 plus 2 times 2 minus 2 cubed over 3 minus parentheses. Set of fundamental theorem of calculus. Plug in the minus 1 here. So I have 1 over 2 plus 2 times minus 1 minus 1 cubed over 3. So what do I have here? This is just 2. 2 plus 4, that's 6, minus 8 over 3, minus a half, plus 2. This would be a minus, that would be a plus, that would be a minus, minus 1/3. What's that going to be? So this here, minus 8/3 and minus 1/3 is minus 9/3, which is just minus 3. So I have 6 minus 3 plus 2 minus a half. So 6 minus 3 is 3, plus 2 is 5 minus a half, which is 9 over 2.
So that step where did you meant to like, set the two functions equal to each other?
Yeah.
Because it says plug one function into the other.
Technically, that's what you're supposed to do. A lot of times it's equivalent to setting one equal to the other.
Okay.
Because if you can solve both of them for the same thing, like you have y equals and y equals, then plugging one into the other is the same as setting one equal to the other.
Okay.
But that's a more technical term because it's not all the time where it's easy to solve for a y value. But if you can't, you just plug in the expression into the y's. You're doing the same thing. Good. Any questions? Right. So the big takeaway here for areas between curves is to identify who's on top, who's on bottom. You do that by sketching. You might have to find the intercepts if they're not given to you, but after that, it's just fundamental theorem of calculus. And the integration for a problem like this would be really easy. It's usually going to be the power rule. You usually won't have to do a substitution or anything crazy like that. That's a separate problem for you.
On the middle section, second from the bottom, you have the straight line of the 2 over the negative 1.
Yes.
What is that notation called, and what does it tell you?
I don't know what it's called, but it's just notation to apply this fundamental theorem of calculus. So it's kind of like if you have a to b of f of x dx, by notation we use that as f of x with a and b, where this is the antiderivative, which is it just means to take the top number, plug it in, minus take the bottom number, plug it in. It just means do this. It's just a notation that says do this. I'm not sure where it came from, but that's how it's written. Let's do another example. Same instructions that I had for this one. Find the area between those two curves. How does that probably look?
Is it going to intersect 3 and negative 3?
Okay, like this?
No, it's positive. And then x. Let's leave it there. 3. You're going to set this as intersect. Is it negative 3?
How's 3 minus x gonna look?
A downward slope that intersects at positive 3.
How do you know it intersects here?
No, on the y-axis it exits.
Okay. Where is it gonna hit the x-axis?
At 3.
Right, you plug in x equals 3, you get y equals 0. So let's put this down a little bit. It's actually going to go through that point. And it's actually very important to know that it goes through that point. Okay, so now what? What else do we need to know?
The other intersection.
The other intersection. So I know one is pretty much given to me. So I know it's going to go through 3, but I need to figure out what's this other endpoint here. It's not going to be minus 3, it's going to be something else. So how do I figure that out?
You said those two equations equal to each other? Or plug one into the other.
So you have 3 minus x equals to x squared minus 9, solve it.
You subtract
A
the.
squared minus 12.
X squared what?
Minus 12 plus
X squared plus x minus 12. Yep. And so that would be?
x. This is about 4.
So 4 and 3 seem to work. You multiply those, you get 12. You can add those and get 1. All you need to do is make sure you have a plus 4 and a minus 3. So this means x equals minus 4 and x equals 3. So we already knew about that, but that's just confirming your answer that it will intersect at 3. And so the other guy here is actually going to be a minus 4. And so with that, we know that the area is going to be the integral from minus 4 up to 3 of top minus 1. Now you look at that shaded region, pretend you're a little man trapped in the shaded region, and who's on the ceiling, and who's on the floor. So on the ceiling is 3 minus x, minus, the bottom is going to be x squared minus 9. You need parentheses because it has to distribute. It's 3 minus x squared plus 9. Or I can have 12 minus x squared. Integral of this?
12x. X squared over 2. X cubed over 3.
So you're going to plug in 3. Minus parentheses, plug in minus 4. And I think I should work on the answer. 243, 43 over 6. Now it's like we're in that cooking show. Well, you put the ingredients like this, you put it in the oven, and boom! Like, wait, what happened? Yeah, I just added those fractions, combined fractions. More examples. Equals x squared. Y equals 2 minus x squared. And here I'm given a restriction. X is between 0 and 4. Curious. Why would they tell us that? Okay, what do we do?
Sketch them.
Sketch them. Good idea. Let's just sketch this thing here. What does that look like?
A frowny face parabola that intersects at 2 on the y-axis.
Okay, so we're talking about, so where would these intersections be? Let's find those intersections. How do we find them?
Set them equal.
X squared equals 2 minus x squared. How do we solve that?
You break down you bring the x squared over to the other side.
You could minus 2, you could, there are a bunch of things you could do here. You could divide both sides by 2 and just get rid of the 2's altogether. You have x squared equals 1. You can bring over and factor a difference of squares, or you can just take the square root of both sides. Either option is good here. So x would be plus or minus 1. So this is a minus 1, this is a plus 1. That's the region. But what were we, wait, is that the region? What were we told here? So I don't want everything. I want here between 0. But whoops, this goes up to 1. What does that mean?
You gotta keep going.
I gotta keep going, right? Right up to x equals 4.
For which function?
And when I say x equals 4 here, there's another area on this outside piece right here. Where between x is 4, the area between these two functions.
Very big.
So now what's gonna happen?
You're gonna change it because the function switched?
No, because this one will keep going to the right. This one will keep going to the right. So 4 is definitely gonna cut them off at a finite position.
Yeah, but they switch. The one that's on top is not gonna be on top.
Yes, they did switch. So what do we do with that?
Panic.
Panic.
Skip it.
Add, yep.
Just skip that question.
Skip it. Just
Do
lose it.
the part you know
Top,
and then stop.
minus bottom, and top minus bottom.
Yes, so the idea is here, you realize that your top and bottom functions actually switched on you. So you think of these as 2 areas, A1 and A2. You're just going to set up 2 of them, right? So the area is going to be, there's one that's going from 0 to 1, right? Now who's on the top in this region? The 2 minus x squared.
Yeah.
Minus the x squared is on the bottom in that region. Plus, now we're going to look at this region. And that one is from 1 to 4. And the top one now is actually the x squared. The bottom one is the 2 minus x squared. Now at this point you have the same function. So you know whatever answer you got here, it's just going to be the negative of it over there. So for now let's focus on this one. This is just 0 to 1. 2 minus 2x squared dx. If I integrate this, it would be 2x minus 2/3 x cubed between 0 and 1. It was exactly the same, except this is negative, so the answer over here is going to be minus 2x minus 2/3 x cubed between 1 and 4. So now,
Can you repeat that?
this is the negative of that. The signs are switched. Who are subtracting? So it's like I took the negative of this and I get that. So now you do the same thing, but you do for each individually. So plug 1 into here, you get 2 minus 2/3 minus 0. That's for the first integral. Minus, plug 4 into here. 2 times 4 minus 2/3 times 4 cubed minus 1, 2 times 1 minus 2/3 times 1 cubed. And did I actually do that one? But yeah, I gave you 4.
Where the minus 0 come from?
Oh, from plugging zeros.
Okay.
If I plug in 0 and 0, I just get 0.
Just get 0.
Yeah, so this is just, it's fundamental theorem of calculus, this is the last part. So this is f of 1 minus f of 0. This is f of 4 minus f of 1. You guys want more examples?
Yes.
And can you allow us time to do it?
Want to try it on your own?
Sure.
Okay, that was
Nothing with fractions.
I want to show you a technique that you don't even,
So that number's so small because as we're moving,
Really? That's the
that's a
one
surprisingly small number.
why?
Because our intersect is at 1 and we know they're growing further apart exponentially.
Not
It's because-
exponentially, they're polynomials. Sure, yeah, it'd be huge, it'd be much larger if they were exponentials, but they're not.
It's not, the picture will radiate. It's not like that.
So I'll do this one example. So sometimes, especially if your graphs are easy, you just graph it. It makes your life a lot easier. Or if you're specifically asked to graph, you'll graph it. But there are some times where you don't have to graph, and you probably wouldn't want to graph. So I'm going to teach you how to get around that situation. Right, so let's say the example was this. So I have one function which is 3x cubed minus x squared minus 2x. The other function is minus x squared plus 2x.
No me gusta.
Now, we could graph it. Do we want to? Not really.
But then how does one?
Yeah, you factor out the x, you get a quadratic, you factor that, you do the three intercepts, you test the points, and then you look at it. Right? And this is just a quadratic, you factor the x and you can do the same thing. Right? So we could, but it would still kind of be annoying.
And how does one figure out what's the top, what's the bottom?
So I'm going to show you how we're going to figure out who's the top and who's the bottom without graphing. Well, it all starts again with the intersections. How's that going to look? Set this equal to that, because you plug one line to the other. So you have 3x cubed minus x squared minus 10x equals minus x squared plus 2x. Where do we solve that?
Bring me x squared plus 2x over to the messy side.
What's going to happen? Well, this will just die. And then I'm going to minus 2x, so I'm going to have 3x cubed minus 12x.
Factor of 3x.
Can factor out 3x, get x squared minus 4. Right?
Oh, that's 3.
And then I have 3x times x minus 2, x plus 2. So I know that x equals 0, x equals 2, or x equals minus 2. Now what you kind of can do here is make an interval. From minus 2 to 2, and there's a 0 in between. And what you can do now is you can actually start testing these points.
Oh.
Right? So all I need to know is who's on top, who's on bottom. Top is defined as the highest y value. Right? So if I say call this y1 and y2, all I'm going to need to do is figure out what these functions are doing on these intervals. So I can test a number here like minus 1, and then figure out what does y1 give me if it's if the x value is minus 1. So I'm going to plug in minus 1 here. It'll give me minus 3, minus 1, plus 10, right? That'll actually give me 6. y2, if I plug in minus 1, it's going to give me minus 1, minus 2, which is minus 3. Right?
So,
Well, this guy here is the top, right? It gives me the bigger y value. Over here I can test 1. See if things switch. So my y1, in this case, if I plug in 1, I would get 3 minus 1 minus 10. That would give me,
Wait, you just picked a random number?
yeah, any number in between 0 and 2.
one's easy.
That would give me negative 8. If I look at the y2, that would give me minus 1 plus 2. That would give me 1. This guy is now the top. So now without graphing, I actually know who's the top and who's the bottom on which integral. So I know my area is going to be the integral from -2 to 0, and in that case, my top function would be the y1, which is the 3x cubed minus x squared minus 10x minus x squared plus 2x. Plus 0 to 2, and things switch. Now this guy's on top, and that guy's on the bottom.
It's the same thing, the function's gonna be just the negative of.
Yeah, whatever answer you get here, you know it's going to be the negative there, you just plug in different limits. And so, yeah, kind of, I don't want to go through that again. Principle. Wow.
Baking oven for 3 hours. Ding dong.
Yeah. You just throw this all together and put it in the oven. Everything's like meticulously sculptured and everything.
I think they had instant dinner. Instant dinner. Yeah, I mean that's kind of it.
I could give you more examples if you want.
Yeah, yeah.
Maybe someone take home.
More like this one that we just
I don't think I asked one like that.
Oh,
No.
thank you.
No.
That was about to be a mess. I don't know my mind.
Omar never believes me.
Nope.
It's like he's lying, man.
Probably trust issues.
Not in the 8 weeks, man.
It's like I've been burned too much by this guy, man. One. So those are 4 curves. Find the area between them.
Can we go through this slowly?
You never said it was gonna be 80 million curves.
That's not 80 million, that's 4.
Two
And
to
it's just gonna be adding multiple intersection dots and then the integral.
So you said it also.
So how are we gonna set?
Equals.
Oh, that's part of the question. Right axis.
Yes.
Definitely
No, that's all like.
No, find the area between all those curves.
This is what I've been talking about, man. That's what I'm talking about.
I'm confused already.
Can't believe you, man.
You can do it, you can do it.
Okay, so this one we can't do,
Okay,
right?
so sketch.
So you
Sketch it.
So right
These
axis.
are super easy to sketch.
Right axis is gonna be like, it's gonna be like a hook, but like extended like that.
That's radical x.
Yeah.
So your 3x squared is gonna be very like skinny. Or is it gonna be very large? Because then 3 does something to it.
Is it?
First off, the
Yeah.
y-intercept is
It's
positive 1,
Yeah.
and it's an upward facing parabola. That
Yeah, so here's the question though. Is it always on top? Or does it cut this guy?
That's what I'm saying, is like.
It did,
What?
Let's find
hold on.
intercept.
I think if it's
The
60 is in front of it, it
three
opens
is
up.
like-
It opens up.
We can figure this out. What about this x1 and 4? How would
they're
that?
literally just straight lines.
Straight lines going.
Vertical.
Vertical.
Vertical straight line. So there's gonna be one line going through here at 1, another line going through there at 4.
It's gonna be big because it's.
It has to,
almost
it has
my
to
line.
like stretch.
Like the
That's
next
the,
line.
it has to stretch.
It's gonna intersect it, definitely.
So how would I know if this parabola intersects those or it stays on top?
You
So-
set the radical x equal to 3x squared plus 1.
So why don't you just plug in 1 into the
You saw for what?
into the equation? Because one should equal the other if they intersect, so if you plug in like some x value and then they come
Yeah, how about I plug in 1? I'd be able to tell who's on top, right? So if I just take 1 and I plug into here, I would get what? 4. If I take 1 and I plug into here, I get 1. So the parabola is bigger. It has to be on top.
Wait,
That's good.
Wait, repeat what you
what?
just said.
Oh, yeah.
Yeah.
This is radical. This is y equals radical x, right?
Yeah.
Now, when my x is 1, it's going to intersect at 1,
Oh, yeah.
right? Whereas if I plug in x equals 1 into the parabola, it's going to intersect at 4. So the parabola, I know, goes like this, right? It stays above. So what I end up is this region here.
Are you gonna put something like this on the test?
You just showed us something completely different.
Well,
Don't put this on
since
the test.
x equals 1 and x equals 4
Yeah.
are straight lines, can't we just set our integral
Intervals.
intervals to that?
Not always. You have to know how these functions relate to each other. Because if one was like this, and there was like that, and let's say there was some other problem, it could have done something like this, right? In which case, this would be my area, and the intersection would be something other than that 4.
But then we would do the same thing again, we just have to separate them and add the two parts.
Yeah, because you'd have to do that. But to know that we have to do that, I have to have a good idea.
So our x equals 1 and x equals 4 really are our bounding edges. of
Yeah,
our-
it turns out, because when I plug in x equals 1 and 4 into each of these, it tells me clearly that there's always one graph that's
I see,
bigger,
I see.
right? It's always the parabola that's going to be above. So
So in
that,
this
the
case-
1 and 4 help me to do that.
So you do the, like you were saying on the intervals, you do large sum before because it's not going to do like a bigger
You do,
No, like you do the area just up until where that x equals 4 like stops.
yeah, like we wouldn't care
We
about
wouldn't
what
care
happens
about this
outside
stuff.
of this
Okay.
window anyway. So that's why I plug in what's going on the edges, right?
That's-
So at that point, I'll know that if the parabola is bigger here, but it's smaller here, then I know, oh, wait, there was a switch or something's up, right? But the parabola is consistently big, and I know the parabola is increasing, so once it's on top, it's gonna stay on top. Right? And so, all right, so how would this integral be set up? Well, it's just gonna be 1 to 4, so those limits are easy. Then,
The integral of 3x squared plus 1 minus radical x.
right, because this is the top, and that's the bottom.
So we don't even have to set anything equal to each other.
No, because in this case, it's clear from the picture that, oh, it's between 1 and 4.
Okay.
Right, so integral of this,
6x.
we're not derivative.
Sorry.
Integral,
3x cubed.
right, 3x cubed over 3, which is just x
Minus
cubed,
3.
plus integral,
That's just x.
integral.
Wait, why did you just put x?
Because
What's
X to the
3 and
power
3
of
cancel.
Oh, yeah, oh. You moved it to-
Yeah, power of x to the 3 over 3.
Yeah, and I see the coefficient.
X to the 3 after
X to the 3 over 2 over 3 over 2. Or 2/3 x to the 3 over 2. 2, 1, 4. So I plug in 4, I get 4 cubed plus 4 minus 2/3 times 4 to the 3 over 2 minus, plug in 1 plus 1 minus 2/3.
Well, that's
Wait.
64 plus what? 68 minus that mess.
68. What's 4 to the 3 halves?
4 squared is 16.
Take the square root of 4, then you cube it. So that's 2 cubed, which is 8,
Eight.
times 2, that's 16 over 3, minus, this would be 2, minus 2 over 3.
Where did you get negative 2/3 x to the
That's the,
Because if we have radical x dx, what rule do I apply? Well, I write it as a power, do the power rule. So I'm going to add 1 to the power, divide by the new power. So 1 plus, that is 3 over 2, over 3 over 2. And then you're dividing by a fraction, the same as multiplying by the reciprocal.
Okay. Thank you.
So I got this.
How did you do that thing with the 302? That's what you're doing? Right.
You got 16 over 3.
Yeah, you took the square root of 4 and then you.
Yes,
cube.
because flower power. Remember?
Oh, okay.
Way back, we're taking it way back.
Wow.
Yeah, so it's radical 4, which is 2, then you cube it, you get 8, So this would be 8 times 2, which is going to give me 16. Or whatever. And then this is 2 minus 2/3. So 2 is 6 over 3 minus 2 over 3, so this would be 4 over 3. So it would be 68 minus 20 over
There's
3.
no escaping fractions.
Sometimes.
They're good teachers, right?
So it's like 68 minus something, almost 7.
Yeah. So you're gonna get 61 and something and change.
What's the?
What?
You see, that's what I'm saying, that doesn't seem like it would be a huge area. I mean, that is a huge area compared to like the other.
Yeah. Well, I'm comparing a quadratic with a radical. Right? Quadratics grow a lot faster than radicals. Radicals grow very slowly. They increase at a decreasing rate.
This might be taking a step backwards, but what happened to all our constants when we take the integrals?
What do you mean? Where?
Forget the plus
Like
C
the-
when we get the integral.
Integral, yeah.
We don't need that because we have a definite integral.
Oh, okay.
The idea is if you have a plus c,
That's
you'd have just a c minus c, so then you don't write it anymore. Y equals x squared minus 2x. Okay, tell me what's the setup. Graph. Start with the graph. Sketch.
Are you telling us to choose what to do?
Yeah, do it. Do it.
Oh.
After that, we can do this one.
How would you figure out which one is top, which one is
Yeah,
bottom again?
that's what
Let's say if you don't, if you forgot how to graph, let's say like x squared minus 2x.
Yeah, that's what I'm saying.
You could do the interval thing. So find the intersection points and then test numbers in between. See who gives you the higher y value.
Oh, okay.
But for a problem like that, I definitely ask you to sketch it.
You say you are gonna ask us this?
Oh yeah, I'll definitely ask you to sketch it.
So can we do this together now?
That's not everybody
You
else.
know it's a parabola, but then only minus 2x.
I found the x's.
Like it's a parabola that does what then? Like,
Yeah, I got.
What is
I got
minus
stuck
2x?
on, X squared.
That's just
It's a positive x squared, so we know it's shaped like this. Now I just need to know what points it passes through. So you find the x and y intercepts. How do you find the x intercept? This is just x times x minus 2. So you know it goes through 0 and 2. So basically the graph is,
You make it seem so easy when you do it.
it is easy. So I definitely ask you to sketch it. That shouldn't take any time.
If it was easy, we wouldn't be here.
It was years ago.
Enjoying
In
summer.
pre-com. Yeah, that's why again, it comes down to knowing the basic graphs. You're just shifting. Something like that next a parabola will always have this shape once the x-squared is positive. All you have to do is figure out what points it passes through, and your x and y intercepts are usually the easiest points to find. So
So
you
the
just
top
find those
is
2
x
points.
plus 4. Yes.
So that's going to be that. And then x plus 4, now it should be obvious because that guy goes, you know, the y by is 4, it's already bigger and it's increasing.
Yeah.
That curve.
So then you have this. So now we're going to have to figure out these intersection points. This guy here, which is at this edge, and that guy there, which is at that edge. Which again, you could have found those two guys and then plug in a random number in between these and see who's higher. Right, which 0 would be a nice number to plug in. Clearly the parabola is below the line.
So it's 4 and -1,
How do we know it's 4 and -1?
because you set the
With
Yeah,
that,
so you're gonna have x squared minus 2x equals x plus 4. That's going to give you x squared minus 3x minus 4. Yeah, you factor that.
x is -1.
That's 4 and 1. Negative 4 plus 1. So yeah, x is 4, x is minus 1.
Would that rule ever fail us?
What, this rule?
Yeah, because before in the original rules you said plug one into the other, and now we're just setting them equal to each other. Is that the same thing with that rule?
It's the same thing here, because I'm saying y is this, and I'm plugging this into that one.
Okay, just making sure. Thank you.
For 205, it's set them equal to each other.
Is that the same thing?
It doesn't get worse here.
What does it get worse?
We don't care.
I get OCD with it. If I say the wrong thing, even though it's effectively okay, I don't like saying it anyway.
That's
Because there are situations you can have, not in this class, where thinking of setting it equal to each other would get you in trouble. You want to think of it as plugging one into the other.
As opposed to like.
In 205, it's going to be. You're always going to have y equals something, y equals the other thing, set them equal to each other.
So you can set up the area as the integral.
Yeah, so area, in this case, area would be
Negative 1
to 4.
negative 1 to 4.
X plus 4.
minus x squared plus squared.
Yeah. Yes. And that's whatever. Oh, this one.
It's like the text, like it's like this. It's like
It's a giant
it's
V.
like arms like going out diagonal.
It's a V.
Yeah,
It starts with the
and at
R.
this point, I mean, on a problem like this, if you get to this stage, you get more than half the points.
Oh, okay.
Like if this was like a 10-point problem, I'll give you like 6 or 7 to get.
Seven. Give it a 7.
Because the rest is just power rule, put in the numbers.
Yeah, passing grades.
No, I'm stopping right there.
What about this one?
You don't want to go for, you don't want to go big?
Nope.
Hey, I'm just trying to pass too.
So absolute x is like a v,
It's like a V.
and then x squared minus 2, it's
But is that
down
negative
2.
two?
There you go.
Oh, it looks like a little flower.
Okay, so there's something cool you can do with this one.
Would it help?
It would help, but let's actually just set it up first. So what do we need? Intersections. How are we going to find those intersections?
Set them equal.
So you have so for intersections, you have absolute value of x equals x squared minus 2.
Okay.
So what happens there?
I guess you kind of have to split that equation into two. So it's like x equals x squared minus 2 and negative x equals x squared minus 2.
Right, because it depends on what side you are, is what the absolute value is going to give you. So you're going to have 2 things to worry about. X equals x squared minus 2 and minus x equals x squared minus 2. The other thing that the idea I was talking about that would help you is, notice that we have symmetry here. So this guy is symmetric about here, and the absolute value is also symmetric. So whatever number I get here, I know I'm going to get the negative number there. And as well as, notice that therefore, across the y-axis, It's literally the same area.
Set it to 0.
So instead of going from minus something to something, I can go from 0 to something and then multiply the answer by 2. So,
I'm not doing all math anyway.
so what's gonna happen here? You're gonna have like x squared minus x minus 2 equals 0. That's gonna give you x minus 2,
That's 2 plus 1.
x plus 1. So you have x equals minus x equals 2 and x equals minus 1. So which one is this talking about? It's going to be here. It's going to be the 2, right? The minus 1 you'd ignore. Why?
And we're going for 0.
He's going from the 0.
Because this is assuming I'm x, it's this line would hit over here at minus 1, which I don't care.
Ah.
So this is the guy I want on that side. Which means ultimately this guy, I'm going to end up with a minus 2 is the guy I want to accept. So now I'm going to have that a equals the antiderivative from minus 2 to 2 of the
Wait.
top function, which is
Wait,
that.
why did you choose though?
What?
Why did you choose these two?
I thought we were gonna go 0 to
Yeah, I'm setting it up.
You're
I'm
writing
going
it out.
to write it up.
Oh, you're taking the furthest?
Yeah, because here it's absolute value of x, not x, right? If I pretend it was x, x would continue going down. So it's going to hit this number. That's going to give me a minus 1.
Uh-huh.
And then this one is going to give me the 2. But this one, of course, I want to ignore. So I would take that one. But then if I take absolute value of x minus x squared minus 2 dx, instead of splitting this into a minus x and a plus x, I just know that this would be 2 times the answer I would get if I just have that. Right? So I just do half of it from 0 to 2 and I double the answer. And it'll give me the same thing.
So this is gonna be
Can you do another option?
Don't
X
put this
squared
on
over
top.
2 minus x cubed over 3 minus 2x between 0 and 2. So 2 squared over 2 minus 2 cubed over 3 minus 2 times 2 minus 0.
yeah, it's 0.
Right, which is nice. That's why you want to split into a half. It gives you a nicer thing. So you have 2, that's just 2 minus 8 over 3 minus 4. Right, let's see that?
Yeah.
That would be a
Look at
plus.
it,
And I'm like, because that would give me a negative area, which wouldn't make any sense. So yeah, so that'll be that. This is 6 minus 8 over 3, which is just 2 times 10 over 3, right? Because 6 is 18 over 3, minus 8 over 3, you get 10 over 3, so it's 20 over 3.
So whenever the graph is kind of like perfectly symmetric, we can just use.
You can
like,
split it in half and
split it
then
in
just
half
work by
times
half
by
of it.
2.
Yeah, that'll work in general.
Will it always work?
Yeah.
If it's symmetrical.
You have to make sure it's symmetrical though. Don't be like drawing the thing crooked. Oh, it looks symmetrical. No, it has to actually be symmetrical. Because these are both even functions, so we definitely have symmetry.
So that whole rule of symmetry gets thrown out the window the second one of those two functions are not a function.
No, not necessarily.
Like you have instead of like
Like you could have something like y equals xn, y equals x cubed, or some cubic where you'd have something like this going on, and then you'd have something like that.
all of those
You
two.
still have symmetry. This side would be the same as that side. So you take it from 0 to 1 and double the answer. So it doesn't have to be even, but you'll be able to tell when something is symmetric. There's one other thing I wanted to tell you guys, but I'll probably just mention it tomorrow. It's not gonna be on the test tomorrow, so I wouldn't worry about it.
Okay, so what's gonna be on the test?
So this is pretty much it. We finished this already. That was so weird.
Okay, so y'all laughing, this is tomorrow. I'm gonna get all of this in your head by tomorrow.
You gotta clap after the final.
No, you turn up after the final.
You gotta wait till you clap. Wait for that grade. There's Jupiter.
So it's gonna be a short one. So basically, I'm gonna ask you three things. Do a bunch of integrals. All right, so I'm just gonna give you like 4 or 5 problems to integrate these. Both indefinite and definite. So if there are numbers on the thing, you should be able to deal with it, as well as if there are not numbers on the thing. I'm going to ask you how to find the error between two curves.
Okay.
So what we were doing earlier, what we just still were doing. 3, approximate an error with a Riemann sum.
That's the right thing.
That's the right time. That's it.
How much time?
45 minutes, maybe.
And the integrand, that's the rules, right? The first thing.
Yeah, so there are going to be stuff where you might have to use a basic, or you might have to use substitution. Definitely, definitely. So the review is already on the website, but that's basically what you have to look forward to.
We can still email you questions and we'll
Yeah.
Professor, maybe this might be a little obvious, but I don't know. I have to ask this. Is there still like homework that we should expect or anything like that?
Yeah, you should be doing homework so as soon as I finish the topics. What do you need?
Yeah, I have to ask that.
Yeah, you should still be handing in the homework. Not just this. Not you do this every day, but you still should be doing the homework.
what time will you
So if you have any outstanding homework, I need them by the day of the final.
Okay.
Oh, we can hand them in.
Look at his face.
I'm about to hug you, man. I know it's
So what about Monday? Do you guys want a mock final or no?
Yeah.
Yes.
Yes.
Because officially we don't have class on Monday, but if you guys want
Really?
to come in, we can do. Yes, tomorrow's the last class,
Oh,
and the final is Wednesday.
Wednesday.
yeah, Wednesday.
Yes. So I figured just having a mock final on Monday, so you can,
Yeah.
try to study everything and be ready for a final by Monday. And then on Monday, you'll know where your weaknesses are. When I just give you everything all at once, you're gonna realize, oh, I forgot that. So by Tuesday, you're gonna brush up on what you forgot, and then hopefully by Wednesday, everything will be nice.
Is there
And what-
tutoring on Tuesday?
Yeah, tutoring goes all the way up to Wednesday.
You'll be there on Tuesday.
Yeah.
What time will you be there?
Usually, the usual 12 to 5.
And
So
when's the
we'll end
last-
there for now.
So
What?
when's the last time I've handed the formula sheets?
Wednesday.
Oh, so-
Keep going for Wednesday.
So
Yep.
literally tomorrow, Monday, and Wednesday?
Yeah, all outstanding homework due after test 2, and the formula sheets, you can give it to me on Wednesday.
And then up to yesterday was when we had to do the integrals on the sheet.
Yeah.
Okay.
No, like, I'm saying, like, is it tomorrow?
So right now, go through the reviews, and yeah. So, then you can do the